Good day to you. I am Safara Adila from UITM Johor, and I'm excited to share with you our innovation titled Personalized Text Simplification Model, Leveraging Hybrid Deep Learning, Supporting Dyslexic Students in Inclusive Classrooms. This project is a collaboration with my colleagues from University Putra Malaysia. They are Dr. Noor Azura binti Husin, Dr. Hazlina binti Hamdan, and Associate Professor Dr. Masra Azrifa binti Azmi Murad. In Malaysia, around 17,000 students are diagnosed with dyslexia. These children face daily struggles in reading, leading to frustration and academic setbacks. Although inclusive education has been implemented as part of the Malaysian Education Blueprint 2013 to 2025, materials used in classrooms, such as textbooks, are still not adapted to meet diverse learning needs. This project was deeply inspired by my own child, who faces daily challenges in reading and comprehending school materials. That personal experience motivated me to design a solution that adapts content to each student's reading and cognitive profile. In Malaysia, inclusive education was officially established under the Malaysian Education Blueprint 2013 to 2025. This policy encourages the integration of students with special needs, including those with dyslexia, into mainstream classrooms. However, when students with varying learning abilities are taught under one roof, teachers often use the same instructional strategies and materials for all. This includes relying on standard expository textbooks, which are not tailored to different cognitive levels. As a result, it becomes harder for dyslexic learners to learn effectively. They face not only academic setbacks, but also increased frustration and lower self-confidence. To address this, our innovation introduces a personalized text simplification model. It serves as a personalized learning intervention that simplifies textbook content based on each student's unique reading and cognitive profile, providing a better path for inclusive success. Our project is guided by three key objectives. First, we aim to increase the level of comprehension of expository texts among dyslexic students in inclusive classrooms. Second, we seek to promote a personalized learning experience by tailoring content to each student's reading and cognitive level. Finally, this project aims to support teachers by enabling them to deliver materials that accommodate the diversity of their students, rather than using a one-size-fits-all approach. Our project is structured into three phases. The first phase, student classification, aims to cluster dyslexic students into mild, moderate, or severe categories. The second phase, text complexity classification, uses shallow linguistic features and deep neural networks to evaluate the difficulty of expository texts at the word and sentence levels. The final phase, simplified text generation, applies an explicit editing algorithm to produce content that matches the student's reading level. Unlike traditional approaches that rely on questionnaires, our model uses handwriting images as the input to classify the dyslexic students into their corresponding severity level. To do this, we employ a hybrid deep learning approach, integrating convolutional neural networks and vision transformers to analyze the handwritings. Furthermore, deep neural networks and linguistic features are combined to analyze the sentence structure for complexity identification. Next, the model functions as an automated tool, not just a concept, but a tangible system that delivers personalized simplification outputs based on student profiles. Then, the model is designed in three continuous and complete phases, all working seamlessly together. Next, we leverage handwriting images as an input for reading difficulty classification. This is a novel data source that is currently underexplored in personalized learning research. Finally, We use real textbook content, not simulated or generic text, making the output immediately relevant and usable in actual classroom settings. This project brings measurable benefits to multiple stakeholders. For the Ministry of Education, the model aligns with national priorities for inclusive education and supports the broader agenda of digital learning transformation. For school teachers, the tool provides a structured way to deliver personalised interventions. For dyslexic students, the impact is direct and personal. The model helps them receive appropriate learning support, improves their reading comprehension and academic performance, boosts their confidence, and reduces learning anxiety. And finally, the project contributes to Sustainable Development Goal 4 by promoting inclusive and equitable education for all learners. Our innovation is ready to be transformed into a scalable educational tool. It could be developed as a mobile or web-based application for use in classrooms or at home. Potential users include schools, special education programs, and edtech providers. The model also has room for future enhancements such as multi-language support and curriculum integration. This project has been well received within the academic and innovation community. It won recognition in the 3-minute thesis competition at both university and national levels. Last year in 2024. It was also published in a Scopus Index journal under Semarak Ilmu Publishing, confirming its scholarly merit. Learning should be accessible to all. Technology can bridge the gap in inclusive education. Through this personalized text simplification model, we aim to empower every dyslexic learner to thrive. Let us join forces in transforming learning for every child. Thank you for lending me your ears. Hope you have an enjoyable time.